right, everybody. Welcome back from lunch. Before we start with this talk, I want to have a short administrative announcement. As I already mentioned before, unfortunately, one of our speakers, George Hanzares, I hope I pronounced his name correctly, didn't make his flight today, so he will be switched out by Thomas Schütz, which is the 2:15 talk at Hall 4, the other hall. Thomas will be talking about KHGPT, the Kubernetes superpower tool based on AI and very, very cool SRE stuff. So yeah, if you're interested in that, make sure to check it out. For our next talk, we have a mathematician from Spain. She's one of the active contributors to the External Secrets Operator project. Please welcome on the stage, Cristina de Dios.
Hi. Thank you, everyone, for coming in today. I'm Cristina de Dios Gonzalez. I'm a software engineer in Amadeus. And for those of you who don't know, which I imagine is most of you, Amadeus is a software company. What we do is provide the software structure for airlines and hotels for them to provide their services. So I imagine, if you want to say, have you ever taken a plane, ever? Yeah, well, you've used Amadeus then. Because it doesn't matter if you go to a travel agent or you go to a website where you compare different prices, you're using Amadeus. And whether you also go to the airline's application or website itself, you're using Amadeus. But it's not only about prices and buying tickets. Amadeus applications also are the ones when you have to book your seat, you have to track your luggage. All of that is Amadeus applications. In fact, I have some data here for you. We are one of the world's leading software companies. Last year, we had 1.5 billion passengers boarded and 396 million total booking processed in 2022. We can imagine that 2023 might even be better because we all know what happened with the pandemic. But yes, you can imagine we are very big. And we have actually the biggest data center in Europe, which is in Erding, where I work, next to Munich. And a couple of years ago, we decided to go to the cloud. We did this with we had a partnership with Microsoft. So our cloud provider is Azure. And this brings many challenges, as you can imagine. One of them is the secret workflow, how to move the secrets from Azure, our keyboards, into our Kubernetes namespaces. This is what we're going to talk about today. How do we do that? Well, spoiler, with the external secrets operator. So let's talk about the agenda that we're going to have today. I'm going to go through the overview of how does the operator work, some use cases. We're going to dive into the resources, some the Amadeus contributions to the project, and then how we deploy it across our clusters. OK, let's start with the overview. So I've mentioned that we use Azure, but the external secrets operator is the solution to move secrets from whatever cloud provider that we have or secret API to your namespace. And what is the external secrets operator? Well, the external secrets operator is an open source project. It's mainly maintained by Gustavo Fernandez and Moritz Joner. What the operator does, as all Kubernetes operator, is that it's based on controllers, which will repeatedly watch over custom resources. They will compare the desired state with the actual state, and if they don't match, the operator will take small actions to make them match. In our case, what we want is to have custom resources in our namespace, so the external secret operator can fetch our secrets and have them synchronize in real time in our namespace. These custom resources, we have them in our namespace, like I mentioned, but we need to have the custom resource definitions in the cluster. The custom resource definitions are just like all the instructions that the custom resources can have, so all the possible configurations. And the external secret operator, as it is by default, should have access to read, create, or delete secrets in every namespace, but we could also, for more security, we could deploy a restricted version of the operator so that for the operator to be able to access the secrets, we could have a specific role binding in the namespace so the operator can access not just all the namespace, but only the ones that are going to use it. OK, let's see a diagram with the flow and the custom resources a bit more. OK, so let's imagine we have a cluster, and we have our we have our application namespace, and we want to create a Kubernetes secrets that is just like this. We want to synchronize from our Azure Key Vault, or whatever Key Vault, that we have into a Kubernetes secret. What do we need? Well, we have our application namespace, and the first thing that we need to have in our application namespace is the service principal, which is, let's say, just the keys to open the Key Vault. And we need our first custom resource. It's called external secret. This custom resource is going to reference the Kubernetes secret to be created, so whatever name that you want, and it's going to also select which secrets you want from the Azure Key Vault. Also, and the last thing that the external secret is doing is pinpointing to the secret store. So the secret store is the other custom resource that we need, because the secret store is going to reference the service principal, so we said like the keys to open our Key Vault, and it's going to have pinpoint as well the Azure Vault direction, so it can be the Vault URL, the tenant ID, the name of the Key Vault, all of that. So the flow goes as we see with the numbers. Like first, the external secret is created. This triggers the external secrets operator, who's going to read the secret store, take the service principal, and use it to fetch the secrets from the Azure Key Vault, and then we can create the Kubernetes secret. Okay, let's imagine now that we want the opposite, like the reverse flow. We have already a Kubernetes secret in our namespace, and we want to push it to an Azure Key Vault, well, to our whatever Key Vault. What we can use is an external secret that is called push secret, which is going to reference the already existing Kubernetes secret, and is going to push it to the Key Vault. It's also going to reference the secret store, so we have the service principal to be able to access the Key Vault, and the operator is going to push it to the other way. As I mentioned before, if we had the restricted version of the operator and we would also need a role binding in the application namespace in order for the operator to access it, but let's pretend we don't need it for now. Now, another use case. What happens if we want to have the same external secret in multiple namespaces? Do I need to create the same external secret everywhere? Well, no. We can have another custom resource which is called a cluster external secret. And as the name indicates, it's a cluster resource. This means it doesn't have to be in any namespace. And what this cluster secret is going to do is recreate the same external secret in whatever namespace that we decide. So in the cluster external secret, we have the configuration that says which namespace, or how are we filtering the namespaces, and what is this external secret going to look like. So the cluster external secret is created. It triggers the operator, who's going to create the external secrets in all the namespaces that we selected, and then we know the flow, as before. The external secret that is referencing the Kubernetes secret to be created, and the secret store is going to trigger the external secret, who's going to check on the secret store, get the service principal to fetch the secrets in our Key Vault, and then create the Kubernetes secret. Okay, nice. Now let's imagine a different use case. Let's imagine we have our service principal in a different namespace than the application namespace. How can we do that? Well, as I'm sure you can think, why not just replicate the service principal, copy and paste it here? Which, okay, you could do, but as I think we know, the less that you replicate sensitive data, the better. So this is one of the reasons why we chose external secrets operator from all the other solutions. I mean, it's also because it's very safe, but this is a really nice feature, because this cluster secret store, which is also a cluster resource, allows you to fetch secrets from a different namespace. So in this case, the external secret that we have in our application namespace is going to pinpoint to the cluster external secret, the cluster secret store, sorry. So it's going to trigger the operator is going to read the cluster secret store, it's going to get your service principal secret from whatever namespace that we have it, and then the external secret operator can fetch the secret from the Key Vault and create a Kubernetes secret. Another question that you may have is, yes, but this seems bit dangerous. Like, what happens if our cluster secret store gets compromised, and then we can fetch the service principal from all the application namespace and replicates them in our application namespace, all the secrets from all the Key Vaults? Well, you can prevent this by having role-based access policies. And so the cluster secret store can only fetch the service principal from a namespace, let's imagine, that have the same quota admin than the application namespace, or that the name of the namespace starts for the same, or that it has same tags, like it's up to you. Just some role-based access policies can prevent that. But for now, let's just keep that in mind. Okay, let's dive into the resources. What do they actually look like? Let's start with the Kubernetes secret, with the service principal secret, which is a Kubernetes secret, and it will look a bit like this, just like we define the two keys that we need, in this case client ID and client secret, and we have our secret here in our namespace. The first custom resource that we're gonna see is the secret store. What does this look like? Well, we see here that we select the API version to external secret, and there's different versions. We set the kind to secret store, we put whatever name, and then we start in the spec with provider. As I mentioned before, and Amadeus only uses Azure, so all our examples are gonna be with Azure. Let's pretend we all work in Amadeus today. But I mentioned that there's a lot of other providers you can also use. And then we say authentication secret reference, and we set the client ID and client secret. Here we specify the name of our service principal secret and the key that we used in the secret before. And last, we select the vault URL, the tenant ID, and the authentication type that we are using. The cluster secret store, which is the cluster resource, custom resource that we have, it looks is very, very similar, with the only difference that when we are specifying the client ID and client secret keys and name of the secret, we also specify in which namespace they are, because we mentioned that we could get it from different namespaces. Now, let's talk about the external secrets, which is the one needing to get the Kubernetes secret and to fetch the secrets from our vault. So what does this look like? We have also the kind external secret. We specify the metadata, which namespace are we, and then we start with spec. The refreshment interval. Here is by default an hour, and this is the time that the operator is gonna repeatedly watch over our external secret and see if it matches with the secret that we created. Then the secret store ref, which is we are gonna pinpoint to the secret store that we just deployed. And target is just to, well, as you can see, is the name to be created in the Kubernetes secret. And the creation policy by default is owner, which means that the Kubernetes secret that is going to be created is going to be linked to this external secret. So if this external secret gets deleted, the Kubernetes secret is going to be deleted as well. But we can also set it as orphan. And then here, we can select secret by secret using data. We see here that, sorry, I think yeah, okay, it doesn't work. By using data, we see, by using data, we see that we can select secret by secret. We can say secret key is where we specify the secret key that is gonna have our secret, so like the key secret value. And in remote ref, the name of the secret in our vault. We can see that there's a difference here because we can say secret, cert, and key, and this is because in Azure there are three types of sensitive data, which is certification, keys, and secret. And if we want to synchronize this sensitive data, but by leaving the same format, we need to specify here in the external secret, and we can say key, certificate, and either we say secret or we say nothing, it's going to be a secret. Let's see some example. So the basic example. Let's imagine we have a secret is with the name app user and the secret value, whatever. So the external secret is going to look, as we mentioned before, we have a kind external secret, we specify a name, a namespace that we are, with a secret store that let's imagine we already deployed. We don't specify a refreshment interval, it's going to be by default an hour, it can also be a minute, a second, yeah, you can imagine. The target is going to be one secret, so the secret that we are going to create is going to be called one secret. And then in data, we say my app user, so this is going to be the key that is going to be created in my secret, that is called one secret. And then in remote ref, I say the name of the secret in our vault, and we can specify a version. If there's many, you can specify one specifically. If you don't specify a version, what you're going to get is the latest version. Now, what do we do if instead of a secret value, we have a JSON format in our secret value, and we just want one of the keys? Well, we can get a external secret just like before, and we specify a property. And here is when we get In this case, we selected user2, so what we're gonna get in our secret is name2, which is the user2. Yeah. Okay, what if I want multiple secrets? Well, you specify one after the other, and you get them in the same external Kubernetes secret, one secret key after the other one. We can also have a very nice feature called template, and we use it, for example, for arranging data. So let's imagine we have 3 secrets, and we want to combine them in just one. So we use data to choose the 3 of them, and then in target, we use template, and we use data again, and then we can specify the secret key that we're gonna get, so in this case sentence, and we have a combination of the secrets that we want. In this case, combination of the 3 secrets that we have in the vault, and then we get simple is beautiful. What else can we do with this template? Well, this is very useful when certificates are all together, let's say, and we want to separate the private key from the public one. Here we can see this in pen format, so we use the template as before, and here we specify these are the secret keys that we're gonna get in our secret, and just by using this configuration, we get the certificate in pen format and separated the private key from the public one. You can have the same for PFX format, base64 decoded, and we can also have built-in types. The default is opaque, but we have them in data. I mean, you take the same secret keys that you specified, and then you can do whatever you want here. This is also very interesting for TLS type certificate, so as you see here, and then we separate the private key from the public one. Okay, what else can we do with an external secret? Do I have to specify all the secrets that I want one by one? That sounds painful. Well, no, you don't. You can also, instead of data, you could use data from, and this means that we can filter secrets. We can filter by name, tags, extract data from JSON value. Let's see some examples because I like them better. Let's imagine we have these 3 secrets, secret 1 with value 1, mystery 2, value 2, and secret 3, value 3. And I want all the secrets that are named secret something. Well, the beginning of the external secret we already know. We have the metadata, the spec, secret store ref that we imagine that we already have, and then target with regeps. So let's imagine this is the name of our new secret. And then we use data from, find, name, and all the secrets that are with secret. So what we're gonna get is secret 1 and secret 3. Here we didn't modify the secret keys because what we get is exactly the same as we have in the vault. We can do the same with tags. So we do use find, tags, tag name, and then in this case, the only secret that has the tag name 2 is mystery 2, so this is what we get in our Kubernetes secret. If I want everything that is inside the key vault, I can just, in this case we're rewriting, but we don't specify anything to filter from, so we get all the secrets in the same format as they are in the key vault. Yeah. Now, let's talk about the external secret from the reverse flow, so the push secret. This external secret, what it's doing is getting an existing external secret. Well, maybe I went too fast. Just to remember, this external secret is going to get the Kubernetes secret that already exists and push it to the key vault. So what we want to have in our configuration, a custom resource configuration, is to, well, same as before, this is the kind push secret. We are in the spec. We select a refreshment interval. We add a deletion policy, a secret store reference to reference our secret store. We select the secret that we want, it's our source secret, and in data, we say to match the secret that we have, so the source secret, and the remote ref, so the key to be created in the key vault. And as we saw before, it can be a secret, it can be a key, or it can be a certificate. And last, but not least, the cluster external secret. So the custom resource that is going to create different external secrets in different namespaces as we want. So here we have the kind cluster external secret, and in the spec we have the external secret name, and the namespace selector, which this is like the most important one because this is going to select which namespace that we want to put our external secrets. Here we're matching by label, so that every namespace that has the label cool is gonna get deployed, but it can also be by name. We have the refreshment interval, the refresh time. This is the time that the operator is gonna check that the cluster external secret and the external secret to be created, they are matching. and then the external secret spec, so everything that is going to be inside the external secret to be created. As we saw before, a secret store ref, the refreshment interval, this refreshment interval is between the external secret and the Kubernetes secret to be created. And then, as we saw before, whatever target that we're using, whatever template and data or data from what we want to use. Great. What are the Amadeus contributions to the project? Well, when we started investigating the project, we playing with it, we used it in one of our clusters, which has so many namespaces and applications that is our dev cluster. And what we noticed, the first thing, is that it was a bit slow. We were facing some delays. And this is because when the moment that you create the external secret, it's going to be instantaneously created the Kubernetes secret. And we were facing like, this was not the case. And in order to investigate why this happened, we were missing a new metric because the operator already has multiple logs and metrics that are very useful, but not exactly this one. So we created a new metric that is just to, yeah, like I mentioned, it just monitors the time between the cluster the external secret is created until the Kubernetes secret is synchronized. Some more unit test coverage, especially with Azure Key Vault, and tag retrieval feature. This was a main issue for us because we were using a secret manager operator before using this external secret operator. So most of our users, so like applications inside Amadeus, were already expecting this feature because the external secret operator was able to give you the value of a secret, but never the tag value. It could filter by the tag value, but never retrieve the tag value. And just so you know how it works, I have more examples. Let's imagine we have a secret with multiple tags, and we create an external secret. I'm not going to repeat it, but when we are selecting the secret, so the same secret key, we have the remote ref. We create a new field, which is metadata policy. By default, is none. But if you put it as fetch, then it's going to take the tags. And then in property, which was used before for whenever a secret had a JSON format, and then we just wanted a value, now it's going to take the value of the tag. So we see here that we selected tag name 2, so we're getting tag value 2 inside my secret key. This metadata policy fetch is not getting now, is preventing for the secret key to be populated with the value of the secret. So if what you want is the value of the secret, you need to create another secret key with remote ref to get it also inside the secret. What happens if I don't specify any property? Well, if no property is defined, what you're going to get is all the tags in the same value as they were inside in a JSON format inside of one specific secret key that you define here, the secret key. And what happens if I want all the tags but in different key names, so if they are not all in JSON format? Well, for that you need to use data from. So we have here that we use extract, the key, so whatever, as before, whatever secret that we have in the vault, and then metadata policy as fetch. And this is going to get all the tags with key name and at the same with the same format that they had before. Okay, lastly, how do we deploy the external secrets operator? Well, we have dozens of clusters, and deploying it manually would be rather painful. So we have an automation, of course. We call it end-to-end automation, which includes different components. Let's talk a bit about them. First, and in the top, we have the ServiceNow, which is another operator. This operator, we're just going to input the cluster size, the landing zone, the region that we want to deploy. And this ServiceNow operator is going to trigger AUDs and Terraform models. AUD is Amadeus specific, is our network firewall. In the case of the operator, is what is going to allow us to connect the external secret pod with the Azure Key Vault in a private connection and secure. And the Terraform models are going to create the Azure resources. So for our clients, the service principal secret that is going to be in the namespace, the resource group, the key vault, blah, blah, blah. But the thing is, for the operator, we don't need any Azure resources. So for us, Terraform is just going to connect the cluster to Argo CD. Now, Argo CD is the one that is going to deploy the Helm charts in the cluster. Where does Argo CD get these Helm charts from? Well, we have our we are mirroring the GitHub repository in a Bitbucket, and every time there's new releases, we updated it. This Bitbucket repository creates a Docker image and a Helm chart based on Amadeus Docker images. And this is the Helm charts and Docker images that Argo CD is deploying. Well, Argo CD also is very useful, and it also allows us to see in the UI all the clusters and all the, each operator, whether it's healthy or not. Sometimes we can also see the logs. And for our clients, our users, they can see if they are deploying it with Argo CD, they can see their custom resources and also their logs, like whether or not they're synchronized, what is the error. It's very, very useful. And thanks to this automation is how we can deploy the external secrets operator across dozens of clusters in a matter of seconds, and the reason why your secrets are safe when you travel. And this is all. Thank you.
Perfect, right on time.
Yeah.
I think you already have the first two questions. Do we?
Nice.
Do we have a mic? Yeah. 1, 2, 3.
Hi, thank you very much for the awesome talk. Actually, I have two questions. The first would be, in the beginning you talked about the service principle which is used to authenticate with the key vault, right?
Yeah, do you want me to find the slide?
Yeah, sure, this one is enough.
Okay.
Basically my question would be if the service principle could also be a workload identity.
Yes.
Okay, awesome.
Yeah, the operator also supports workload identity.
Awesome. And the other question would be about the functionality of pushing secrets from Kubernetes to the vault, because this would enable us to migrate, for example, HashiCorp Vault to Azure, because we're syncing our secrets from Vault to Kubernetes right now, and we want to migrate to Azure. First question here is, can I sync all my secrets from a namespace? Is there a selector for this? Because you only showed sync this one secret.
Yeah. That I know you cannot use data for push secret.
Yeah.
But yeah, maybe it's a feature that we can think about in the future. We are not really using push secret, so not really into that. But yeah, I mean, you can specify one secret at a time and it pushes it. Oh, well, it depends, because if you have in one secret all different keys.
Yeah, we have multiple secrets actually.
Yeah. Okay. I see.
Okay.
Yeah, different. But you could use data and then go one by one.
Yeah. And if I would delete the external secret, which is pushing, would it delete the external secret then?
I'm not sure. I don't think so.
Okay.
But it is, as far as I know, it doesn't have a creation
There's
owner.
this deletion policy, right?
Yeah, deletion policy. Yeah, I'm not sure. I will have to check.
Okay.
I can get to you later. I think.
Thank you very much.
Yeah, same. Great talk. I have a question. Can you speak to when is it decrypted? So because the Kubernetes secret is still just encoded, right?
Yeah.
And I guess everything else is encrypted?
Yes.
Exactly. Where exactly does the encryption happen? Decryption in this case.
So maybe I don't know if I get the question right. So you're asking because we are encrypting the secret and then decrypting it. So you have
in the end it
secret.
has to be decrypted, right? It's just encoded. So, and I guess the other parts are encrypted, right? In this black thing, still encrypted, is it?
Step number 3.
No, not push, pull. When I'm pulling them.
When you're okay.
The normal workflow.
Let me just so we are.
Yeah, almost.
Yeah, here. Thank you.
Yeah, fetch. All right.
So you're saying it's encrypted, and when? So you're asking me when you're decrypting it?
Yes.
So in here, like in the moment that you create it, in decided the secret operator, you decrypt it, and then you create the Kubernetes secret.
Okay, so there's not one decrypt. Okay, so it's one decryption key that lives somewhere in this middle box. Okay, so it's one key. It's not many keys. Okay.
No,
cool.
it's one.
No, it's not. It's not. You can store multiple secrets in this black thing, right? It's not the service principle that encrypts. Now this is for the authentication. I'm talking
the
encryption.
keyboard, and then you can create multiple secrets. Yeah. I'm sorry, maybe I'm missing the point. Okay, we can talk later, maybe. Yeah.
So, do you do secrets rotation?
Yes. So, like I mentioned, the external secrets operator is repeatedly watching over. So, whether the secret is expired or
I know.
Ah, okay,
You've shown us that it will query in an interval, but how do you handle overlap?
What do you mean? How do you
You
handle
say
it?
I change the secret at
In the vault?
point X. Yes,
Okay. And then how is the secret going to be updated here?
exactly, because you haven't shown us if there's a push mechanism. Otherwise, I would have the problem that if I were to kill a pod in exactly that moment, the password won't match anymore.
So you say if you
So,
let
sorry,
me start. Yeah.
example.
Yeah.
I have a database, and I have Azure somehow update the password from my database user and put it back into Key Vault.
Okay.
So I have to sync that password to my cluster, or else my application won't be able to connect anymore. So I know HashiCorp Vault can do this. It can auto-rotate database user passwords. And there I would have the problem that I need to have the password at the exact time in the cluster, or else I might run into problems if my pod is restarted.
Okay. If your refreshment interval, let's say, it's too big because you need it immediately right away, you could force the synchronization by either you could delete the secret, for example, in Kubernetes, and then the operator would be forced to create one again. You could create and you could delete the external secret and then recreate it. But if you don't do any manual action, eventually the external secret operator, because like I mentioned, I'm sorry if I'm repeating, is gonna watch over the external secret. Is gonna see that the secret in the vault is not matching the one in Kubernetes, and then it's going to update it.
Okay, thank you.
Okay.
All right. Any more questions? I just see the light.
Hi.
Hi, thank you for the presentation. This concept is not extended to pods because we are injecting secrets at the namespace level, and my application might be deployed in the same namespace but needs different pods. Therefore, the same secret would be accessible to all the pods in that namespace. Is that correct? Is in the pipeline to extend the concept to pods as well?
This is not a use case that we have, so I'm not sure. But it might be that within the project, some people are willing to contribute with this feature.
Thank you.
Thanks for the talk. One question, I mean, you kind of inject the secret, so it's in the Kubernetes API, and I guess it's then encrypted by in etcd. But have you ever thought about extending that maybe to decrypt the secret at as a init container? Because on demand. So when it's needed, it's decrypted. Because here it's kind of if you misconfigure your RBAC, you kind of can just read the secret, right?
Yeah.
And I mean, you run it, I guess, in your company, and you have a large company, so I guess you thought about this. So how did you treat this potential threat for the secrets?
So you're asking me whether or not the operator can decrypt it on demand, the external secret, the Kubernetes secret?
My question goes more into the direction, I mean, the way the operator works is kind of it decrypts the secret from your vault where you fetch it and then puts it in Kubernetes.
Yes.
And at that time, it's already decrypted. So if somebody has RBAC access to read the secrets, you can kind of just have the secret, right? And there is no need to have it decrypted in the Kubernetes API because you would decrypt it when you need it. And when do I need it is when my pod runs, right? So one aspect would be to run an init container and decrypt the secret and then maybe put it in a, I don't know, RAM-based file, so it's never written to disk. Have you thought about this use case? I mean, that's why, or what implication has it for your company that it's a plain text secret in Kubernetes? Have you? So that's basically my question.
I mean, good question. Okay, if it is a plain secret in Kubernetes, but not everyone has access to whatever namespace, which is for the role-based problem. So if a namespace, let's say, rights gets compromised and someone can access, yes, someone can access the secrets. I don't think I have a solution for that right now. But what we could do is to whenever we find that we have an intruder, we could block the namespace so we cannot access to any more vaults, and then other contention recovery plan. But
There's a standard for this. I mean, it's also good. Like, how do you? Yeah. Just a comment because there are solutions. I mean, there's a pattern in Kubernetes to encrypt secrets in etcd. So it's orthogonal to that, right? So you have like the dual encryption, dual envelope to have secrets encrypted in etcd. That will solve the issue. But it's orthogonal. So I think you can have this mechanism and another mechanism to encrypt secrets in etcd. That's different things.
The question is that enough?
No, yeah, that's the point. Actually, this is one portion, but in my opinion, it's not enough. So I would suggest to check a project that is called Trousseau, like the French word, that is based on the Kubernetes standard, the envelope encryption, that can help you encrypt etcd secrets in etcd using any KMS and things like that. So check out Trousseau.
I think maybe at this point we can have the discussion somewhere at the coffee table since don't want to interrupt, but we're already in the break. So we'll have the next talk in about 10 minutes. One of Red Hat's most renowned engineers will talk about pod security admission at this stage. So make sure to be back at 10 minutes.
Thank you.